Hi you guys, here's Carol, and we're going to have a little quiz session here where I'm going to show you some molecules and you're going to recognize them. You're going to tell me whether it's a carbohydrate, a fat, a protein, or a nucleic acid. Okay, ready? Number one, this first one here, you look at it and you see, no nitrogen, can't be a protein. Let's see, could it be a fat? Let's count whether the number of oxygens and the number of carbons is alike. So we have 6 carbons down the center there, and 1, 2, 3, 4, 5, 6 oxygens. So they have equal number of oxygens and carbons, and if those are going to match, it's going to be a carbohydrate. What about this one? Do they match? The oxygens and the carbons. So in this picture, the little black balls are carbon, the oxygen are the red balls, and the little white balls are hydrogen. So we don't have equal carbons to oxygens because we've got very few oxygens here. So it's not a carbohydrate. It's got 3 in a row here, which is a triglyceride. So we know that that is a fat. This is the glycerol molecule, and then triglyceride. That's a fat. Next is a protein. How do we know? We know that this has got to be a protein because it's got this part, an NH2 and a COOH. You find that? You got it. It's a protein. And R here means that there's something else. All the amino acids look like this, and then attached onto here will be the part that's different, but everything else is the same. What molecule is this? So let's check again on whether the oxygens match the carbons. Do I have equal number of oxygens and carbons? No, not a carbohydrate. Do I have NH2 and COOH for protein? No, not protein. So this is a fat, and we'll go through the nucleic acids later. It's a fat. When we have something that has a nitrogenous base, a 5-carbon sugar, and a phosphate group, it's a nucleic acid. So anytime you see a phosphate, a 5-carbon sugar, and a base, you know that it's going to be the nucleic acid. But let's keep going because there'll be more. Again, a long chain of carbons, lots of hydrogens, but we're a little low on the oxygen. So this cannot be a carbohydrate. This has got to be a fat. What about this one? So what are we looking for? I can spot a COOH and an NH2, and then something different there. It doesn't matter. I've seen the NH2 and the COOH. I have a protein. All right, number 8. We have this long chain. This looks like a glucose. So we have it in a ring form, and it's attached onto another ring form and another ring form and another ring form, and it's making this long chains of carbohydrates. What about this? This is this could fool me thinking, I have a protein, but where is the NH2? Where is that? Nowhere? It's a fat. Okay, this one has the NH2 and the COOH. This is a protein. Here I couldn't count carbons again. 6 carbons. 1, 2, 3, 4, 5, 6 oxygens. So I have carbohydrate, particularly glucose. This is what you had to do your exercise forming this molecule. You had to form this molecule with vegetables or grapes or whatever you'd like. Good. Okay, so let's see. I come here. I have no idea what's going on here. I don't recognize this. I'm not sure what this is, but I have my NH2 and I have the COOH, so I know I'm talking about a protein. In this case, these are all amino acids. They're small. It's chains of amino acids make a protein. This is a steroid. I didn't talk about those before. So I recognize them by these rings. Again, we don't have that ratio of oxygen to carbon because there's carbon here on every one of these corners. And just whenever you see these double rings, you're talking about a steroid, which is a fat. Now what do we have? So we have a phosphate, a 5-carbon sugar, and a base. So here we have to be talking about a nucleic acid, making up DNA, for example. Protein. Now let's look at this again. So here we have that triglyceride again, and the glycerol molecule in blue. There's something funny here that has a kink. And so this is saturated, and this is unsaturated. We say it's unsaturated when we're missing a few hydrogens. We're missing hydrogens because there's a double bond, and so instead of sharing with an electron with another hydrogen, instead it's sharing an extra one with itself, with another carbon. So that shape forms a kink in the chain, and I know then that what I'm talking about here is a lipid or a fat. Nucleic acid, phosphate, sugar, and nitrogenous base. This is a steroid. It's usually these six carbon rings and then 1 5. And that's the end of that show. So that's how you practice those. See you next time.